Well, here we are, the last video for this semester in Mr. Levine's geometry class. Oh, don't cry, little Johnny and little Susie. It's okay. Santa and Hanukkah Harry are still coming this winter to give you your presents. You just won't get to experience the thrill and joy of watching a Mr. Levine video for the rest of the year. But don't worry, I'll be back next semester. What I want you to write down, little Johnny and little Susie and everyone else in class, is I want you to draw a triangle. It doesn't have to be on a piece of paper that has color on it. It can just be a white piece of paper, whatever piece of paper you have, and cut out the triangle. This will be something I want you to show. Your paper either has a triangle cut out or glue what we do onto your piece of paper. But you're going to cut out a triangle and you're going to write the letters A, B, and C and the interiors of the angles. Then you're going to cut or tear off the angles from A, B, and C. And you can see that I've done that. I showed you over here what you do to cut it. And then I showed you, I took a little picture of these so I could separate them, what it should look like. And I want you to show their sum. And to show their sum, you need to arrange them in a way where all their angles, so where A is and where B is and where C is, all meet at one point. So I put A and B, and I have their angles touch, and you're just rotating them. C was already in a good spot. I shouldn't have moved it. There we go. And again, it's going to be easier for you to do this because on the computer screen it's not going to be perfect. And you fit them in, and you will see that they form something. And I want you to say what their sum should be. Based on what they're forming, what should their sum be? And what happens is, if you do this right, it'll form a line. And a line has 180 degrees in it. So their sum should be 180. So please write that down. Their sum should be 180. And that brings us to the triangle sum conjecture, which is the sum of the measure of the angles in every triangle is 180. My hope, and I'm pretty sure that every single one of you knows that. Now we've shown why, we've proven it. For this, this is going to be an extra credit problem. A lot of you probably don't even know what an auxiliary line is, which is kind of evil on my part. I would do an evil laugh here, but I'm not in the mood. I'm too happy. So if you know what an auxiliary line is, or look up what an auxiliary line is, we'll go over it in class. But I want to see, for extra credit, we'll say 20 points extra credit, if anyone can tell me what the measure of A, B, C is. Measuring it's not going to help. This is not to scale. This is not to scale. There's something you have to do with an auxiliary line that will go through B to be able to figure this out. So pause it if you need to think about this, but I'm moving on. Now we have the BS theory. What a great theory, the BS theory. I watch the BS Report with Bill Simmons, one of my favorite podcasts to listen to. But I want you to find all the B's and to find all the S's. And what you can see right here is that I've given you a B and I've given you an S. Okay? The B and the S. Using alternate interior, exterior corresponding vertical angles, I want you to find all the B's and all the S's for the BS theory. And I want that to be in your notes. So pause it if you need to pause it. Then for, let's say 30 points extra credit and 2 pieces of candy, explain why the triangle sum conjecture is true for every triangle. And this is going to be a proof. And you are going to have to use an auxiliary line. Okay? The reason these are so much extra credit, I'm not trying to taunt you or tease you. Again, I get that it's evil. But I mostly just want you to see these, so when we go over them in class, you've seen them at least once. And then if anyone gets it, I'll be so impressed that I'll give you something. I'm not expecting anyone to get these. And if they do, that's awesome. But explain why the triangle sum conjecture is true for every triangle. Then we have here an isosceles triangle. So I want you to draw your own isosceles triangle This should be in notes that you're going to keep. This is something I want you to know. The base angle is the legs and the vertex angle. And the key here is to remember that an isosceles triangle can be facing any way. And I want you to see, and I have a little picture over here, that this is still an isosceles triangle. This is still an isosceles triangle. And your base angles are still the same spot, even though it's turned. Like, it's not like all of a sudden this and this become your base angle. The base angles are the angles that are opposite the legs. So we have our legs right here. The base angles are always opposite those. You can see how it's opposite, the arrows. Opposite angles are going to be the angles that do not touch the side. So if you look, let me erase this. If you look at this side that I'm highlighting in yellow, it does not touch this angle. The other two sides touch that angle. So the opposite angle is the one that does not touch the opposite side. So I want you to draw an isosceles triangle using a ruler or a compass. And then I want you to measure the base angles and say what you notice. And then if a triangle is isosceles, then what do you notice about the base angles? And that's it. That's our video. I'm not really going to miss any of you since I see you in class every other day. But I will miss making these videos until January. I'll actually make them in December, but you will see them in January. Have a good evening.